Continue from our previous video. We try to find what is the standard deviation of the 0-1 population. So we show you one is when the number of the 1 is 2, we have sample size 10, standard deviation about 0.4. So then you see here, how about we change to 4, we run again. Standard deviation is 0.49. So then you have 6, you run again. 0.49. Then 8, then you run again. They're back to 0.4. So it's kind of like standard deviation for the 0-1 population, kind of within a range. So how about we try to list all the standard deviation for 0-1 population. According to the number of 1, we can start from 0. Yeah, because you can have 0, 1, but also you can have 10, 1. So they are between 1 to 10. So then for each one, we list standard deviation for that population. Okay, so that's why here is our function to find the standard deviation according to how many 1 in that sample. So we have our, let's make a range for the array is from 0 to 10. So you can from 0, 1 to 10, 1 from that sample size. So then we make our table. On the first column is the number of the 1. The second column is the proportion of that 1. So that's just divide by 10 for the total, right? So then we have our table. So you see we can have 0, 1 or 10, 1. Okay, then the proportion will be from 0 to 1. Again, we care about that is the standard deviation, right? So that's why we find the standard deviation for all the data. So then we add to our table column. So then you will see standard deviation for the sample size 10. According to how many 1 we have, that's our standard deviation. So then you can find out the standard deviation actually start from 0. Then they become bigger, but until they have half 1 and half 0, the standard deviation is 0.5. That's the greatest one. So then later on they bring down. So this time we see the scatter plot will be even better. Okay, so then you can see here. So that's our standard deviation. And yeah, I cannot show you the whole thing. Okay, I need to find a way to make my screen size is a little smaller. Okay, so that's why you can see actually they kind of like is the curve. So this one told us what? It tells us actually your 0-1 scatter on your 0-1 sample proportion. The most standard deviation is 0.5. Yeah, of course you will say, hey, you just have the size is 10. Okay, but if you want, you can do your size equal to 100. Okay, so for example, you can see here we can do for 100. Okay, at most we have 100. So on the other hand, this one become 101. Okay, so then your 1s is need to divide by 100. Okay, so after you have this, okay, so then you have your sample size is 100, but you need to list all the combination. So that's why here you also have your standard deviation. But then if you try to plot, yeah, so they have more data, they have more more different cases for the sample size is 10. But no matter, sample size is 100. But no matter what, the standard deviation at the most is only 0.5. So after we know the standard deviation for the 0-1 proportion, the maxima is 0.5. Then we can go back to see our question. Because earlier we showed you, in order to find the sample size will be equal to 4 standard deviation divided by 0.01. That's our the width for the 1%. So then, since we know the standard deviation for the 0-1 population, this part at the most is 0.5. So then we can add the inequality because at the most is 0.5. So that's why the sample size square will be greater or equal to 4 times 0.5 divided by 0.01. So then you try to take the square on both sides. So that's why our sample size we can get is 40,000. So the sample size should be 40,000 or more. So that's we can have our total width for our 90%, 95% confidence interval is the interval is 1%. So check, make sure you understand. If you have any question, you can post your question on the discussion or discuss with your classmate. So this sample proportion, remember it only used for the categorical data. And we only have two categories, two results. They're either yes or no. So that's why we can do the 0 or 1. So this one actually is very interesting. Since your standard deviation for the 0-1 population is always within 0.5%. So that's why here this sample size within 1% interval. So 1% interval actually is including positive, negative standard deviation, right? So that's why the margin, the error margin actually is 0.5%. So no matter you use for which kind of 0-1 population, the sample size actually is the same. And the sample size you need is the same. So that's why we see here about our discussion. Okay, so the first discussion question is, they ask you, can we poll only 1,004 Americans represent 260 million people with only a 3% margin of error? So you can see even your population is 260 million. Okay, so here sounds very crazy. 260 million people. You're only using a little more than 1,000 people to do the poll. So that can get only 3% margin error or not. So this one is a good example because we do the poll. They just either vote or not vote, right? So we only have two outcomes. So that is a 0-1 population example. So if this one is a 0-1 population example, on the other hand, they are fit into our function here, our equality here. So the only different thing is this one is we say the interval is 1%. Okay, so for this question, since we say 3%, so here actually, let me write it down. So when we say the 3% margin error, that's mean plus minus, right? So that's mean the true standard deviation is 3%. So that's mean the total interval. Okay. Yeah, since I'm recording, so that's why they block, I cannot really write. So anyways, the 3% margin error, that means your total interval is 6%. So that's why we just need to go back to see this equation. And we replace this one here, the 0.001 become the 0.06. So then you find your sample size and compare, are they close to the 1,004? Okay, so that's our first discussion question. So make sure every discussion question, make sure you will pause that on the video, pause that video and also discuss with your classmates. Sorry, I forgot to do the previous one. But now here, maybe we can do this one. Okay, so this one is a little different. They say the researcher is estimating a population proportion based on a random sample. So we have the sample size already is 10,000. So with the chance for the at least 95%, that means the confidence interval is 95%. The estimate will be correct to within how many percent? Okay, so that's on the other hand, you need to find the interval for that. So then the interval divided by half, that will be your margin error. So pause the video, then make sure you will run for the answer. Discuss with your friend and get the answer before you continue to see the solution. Okay, so I'm sure you already discussed with your classmates, right? Okay, so now this question is, we had the random sample size is 10,000. So we want to find under the 95% confidence interval. So what is the range for that? So that's why actually this one we will go back to the beginning for here. Okay, so our sample size is square root. Okay, so here since our XD of the 0-1 population will be at the most 0.5. So that's why you can 4 times 0.5 divide by the square root of the sample size. So then we can get our interval. That means the 4 standard deviation. So then if you want to say the margin, so here after you calculate will be 2%, but 2% actually is the whole interval. So it depends on how you want to say the correction. So this one estimate will be correct to within kind of is margin error. So that will be plus minus 1%. Okay, so here this one is discussed question. The margin error for the sample size is 10,000. So that's why you can find the value here. Okay, so then that's why the interval is about 2%. But that's the total for SD. So margin error is 2 SD. So that would be 1%. Okay, so then you can see the last question as well, since we have time. So then here they say they're going to use a 68% confidence interval to estimate the population proportion. Okay, so this one mean what? 85%. Before we say 95% confidence interval, that's 2 plus minus 2 SD. So the 68% confidence interval, you can go back to see the previous lecture. So that will be 1 SD. Okay, so plus minus 1 SD. So I want the total width of my interval will be no more than, so total width of no more than 2.5%. So on the other hand, that's mean 2 SD are not more than 2.5%. So what's your random sample size? Okay, so make sure you discuss with your classmates before work on that. Okay, so how to do this question? So that will be similar, right? So only difference is before we all use the 95% confidence interval. So now we use the 68% confidence interval. So that means the standard deviation we only allowed from the population mean. Left to the right, only 1 standard deviation. So that means the total width of the interval only 2 standard deviation. So the same thing, you still can go back to use this formula. Okay, but the only difference is our standard deviation is not 4. So only become each size 1. So that's why total only 2 standard deviation. So you need to replace this with 2. Okay, but standard deviation of the 0-1 population is still 0.5. So then again, here since we say they want to have 2.5%, okay, so they want to the total width of the interval no more than 2.5%. So that's why the same thing when you go back to see this one, then this one you need to replace using the 2.5%. That will be 0.025 to replace that. Okay, so then again we can calculate from the Jubic notebook. So the sample size for 68%, yeah, change this one become 2. So then the same thing, the standard deviation for the 0-1 population will be at the most 0.5. So then here is 2.5%. So again, the same thing, we take the, we square that. So then you will see the result will be 1600. Okay, so that's our lecture 28. So you can see here has more calculation question. So please make sure you understand each one. And if you have any question, discuss with your classmates, and feel free to join the office hour or just post the question on the discussion board, so then we can talk more about that. So then, right, so after today's lecture, make sure you will work on your homework assignment 9. So that's for the lecture 28. Then we're done with